Hello everyone, welcome to my channel One Concept Only. This is one of the DC machine question. Let's solve this question. Given it is a separately excited DC generator and armature resistance of 0.1 ohm and total drop across the brushes is 2 volts. Initially it is running at 1000 rpm and is delivering a load current of 100 amps and terminal voltage of 250 volts. Means the load resistance will be Vt by IL. Terminal voltage is given as 250, load current of 100 amps, then load resistance will be 2.5 ohm. If the generator drops to 700 rpm with field current unaltered, field current unaltered means flux is constant. Flux is constant. Under the same load condition, what is the current delivered to the load? Let's write down what are the basic data they are given here. Here it is given a brush drop of 2 volts, armature resistance of 0.1 ohm. Initially, it running at a speed of 1000 rpm. It is delivering a load current of 100 amps and terminal voltage of 250 volts. By this, I found the load resistance will be 2.5 ohms. In case 1 means the machine running at 1000 rpm, the generated EMF will be E equal to Vt plus IaRa plus brush drop. By substituting above data, I am getting a generated EMF of 262 volts. Here, in this condition, the given field current is kept constant. Means IF is constant. IF is constant means flux will be constant. Flux is proportional to field current. Flux will also be constant in both case 1 and case 2. By using the formula E equal to K into phi into omega, K is a constant, flux is also constant, then E1 by E2 equal to IF1 by IF2 into N1 by N2. Here IF1 equal to IF2 means both cancel each other. By substituting the induced generated EMF in case 1 is 262, generated EMF in case 2 1000 by 700 means we get a generated EMF of 183.4 volts. Here the given load is kept constant, means load resistance will be 2 ohm, 2.5 ohm only. There will be no change. Load resistance is 2.5 ohm. Load resistance is 2.5 ohm. Here in case 2, generated EMF is 183.4 volts equal to Vt plus IaRa plus brush drop. By using the formula Vt by RL equal to IL, substituting Vt equal to IL into RL in this particular expression. By substituting Vt equal to IL into 2.5 plus IL into 0.1. 0.1 is an armature resistance. IL into 0.1 will be armature resistance drop. This is brush drop. By this, I found a load current of 69.77 amps. Mainly in separately excited machine, the graph between Vt and IL is an external resistance, external characteristics. Means at speed equal to constant. Means Vt and IL graph at speed equal to constant is external characteristics. If the machine is running at 1000 rpm, it is drawing a current of 100 amps at the generated EMF of 250 volts. If the speed is dropping to 700 rpm, means by a drop of 300 rpm, then machine delivering a current of 69.77 amps at generated EMF of 183.4 volts. Here in this particular graph, I am neglecting IaRa drop. If IaRa drop is also included, the terminal voltage will drop like this in both the cases. This is very good question. If you want To solve this sort of question, please subscribe to my channel.